Welcome back to multiple choice section. We'll continue with question 26. Given f of x equals ax cubed plus 3 and gx equals bx minus 1, the graph of the product f times 3 passes through the points negative 1, negative 3, and 1, 9. We need to find the values of a and b. So we start off by finding the equation of f times g. So which equals ax squared plus 3 times bx minus 1. As you can see here, we're missing the coefficients a and b, and to find these two coefficients, we'll have to use the two given points. So the first point has the coordinates negative 1, negative 3, which means that when x equals negative 1, the value of f times g will be negative 3. So that would be the y value. And when x equals positive 1, the value of f times g would be 9. So the y value of the combination of functions will be 9. So we're going to start off by substituting the first point, negative 1, negative 3, into the combination. So that means we have negative 3 equals a, x is negative 1, so negative 1 squared plus 3, and then multiplied by b, x is negative 1 again, and then minus 1. So we'll simplify. We have negative 3 here equals negative 1 squared is positive 1, so we have a plus 3 here, and then multiplied by negative b minus 1. I would leave this equation in factored form, so because I noticed that the other point will have the x coordinate equal to 1, so most likely we'll get something similar on the right side of the equation. And I will call this the equation number 1. We'll continue in the same fashion with the next point. So the next point has the coordinates 1 and 9, which means that 9 equals a, x is equal to 1, so a times 1 squared plus 3, and then b times 1 minus 1. So 9 equals a plus 3 times b minus 1. So this would be our equation number 2. We'll call this equation 2. It describes the relationship between a and b. So in order to solve for a and b, we need to eliminate one of the variables. So we're going to put the two equations in a system, and we'll try to eliminate one of the variables. So what we have in here, or what I'm going to start with, is rewriting the equation 2. So a plus 3, b minus 1. And underneath it, I'm going to write the equation 1. So negative 3 equals a plus 3, negative b minus 1. So in order to eliminate one of the variables, it would be easier in this case if we divided the two equations. So if you divide the two equations, then we can simplify a plus 3. And that will eliminate the variable a. So therefore, we're going to have 9 divided by negative 3 equals a plus 3 times b minus 1 divided by a plus 3 negative b minus 1. So here we go again. We have negative 3, that's 9 over negative 3 equals a plus 3 simplifies, and we have b minus 1, negative b minus 1 here. So solve the equation. You can use cross multiplication if you wish. So there we go. And we have negative 3 times negative b minus 1 equals b minus 1. So this will give positive 3b plus 3 equals b minus 1. 3b minus b equals negative 4. So that will make the value of b equal to negative 2. So the value of b is negative 2, so I'm searching for the options in here, and I see that this is b of 10, so that cannot be an option. This is b of 2, so that's not possible. B equals 2, so it seems that we're either have to go with options D or E. So we need to find the value of A in the meantime. So to find the value of A, we're going to use the equation, either equation 1 or 2, but I would go for equation 2 because I do not have a lot of negative numbers to deal with. So if 9 equals a plus 3, b minus 1, it means that 9 equals a plus 3 times negative 2 minus 1. So 9 equals a plus 3 times negative 3. I'm showing all the steps here because I don't want to lose anyone if you are following the calculations. Obviously, this is a very simple linear equation to solve. Divide both sides by negative 3, and that will give us a plus 3 on one side equals negative 3, so a would equal negative 6. So the a value should be negative 6, which means that the best option to choose in this case would be option D. So D is the answer. Let's continue with the next question, number 27. Given the rational function f of x equals 4x minus 3 divided by 2x plus 1, what are the coordinates of the point of intersection of its vertical and horizontal asymptotes? So we are talking about the vertical and the horizontal asymptote. So we need to find out what the vertical asymptote is. Remember, we find the vertical asymptotes by making the denominator equal to 0. So for vertical asymptote, 2x plus 1 has to be 0, which makes that x equals negative 1 over 2 will be the vertical asymptote. For the horizontal asymptote, we have to first examine the degree of the numerator and denominator. So it seems that they're both same degree, degree 1, which means that the horizontal asymptote will be given as the ratio of the leading coefficients. In this case, 4 over 2. So the horizontal asymptote will be, I'm going to write it down here actually, y equals 4 over 2, which is positive 2. So a vertical line at negative 1 over 2 and a horizontal line at y equals 2 will intersect at, I'm going to draw the negative 1 over 2, let's suppose that's where it is, and y equals 2. So they will intersect at the point where x equals exact same as the vertical asymptote and y equals the same coordinate as the value of the horizontal asymptote. So negative 1 over 2, 2. It's not A, it's not B, it's not C, it's not D, and it seems that the last option, E, is the correct answer. Next question, number 28. Given the function 3x squared plus 6x minus 24 over x minus 4, the equation of the one of the asymptotes is y equals x plus 6. So as you can see in here, this would be an oblique asymptote, horizontal asymptote, oblique asymptote, and this one here will be a rational function. So it's neither horizontal nor oblique. So first of all, I would exclude the options that cannot be possible. So in this case, this will go first because the asymptote cannot be in rational form. And this one here has to go as well because this function does not have a horizontal asymptote. So why do we think that, or how can we make that decision? If you look at this rational function, the degree of the numerator is 2. Degree of the denominator is 1. So there is a difference of 1 degree between numerator and denominator, with numerator being a degree higher. So in these type of rational function, typically we obtain oblique asymptotes. And to find the oblique asymptotes, we simply divide the numerator by the denominator. So we'll go long division here. So 3x squared plus 6x minus 24. And we'll divide it by x minus 4. So remember that we first look at the first terms. X goes into 3x squared 3x times. So multiply 3x by x minus 4. So that will give 3x squared minus 12x. Subtract the entire thing. So 6x minus negative 12x would be equal to 18x, and bring down the negative 24. Again, x goes into the first term, which is 18x this time, 18 times. So plus 18. So this will be 18x minus 18 times negative 4 would be equal to negative 72. And at this point in time, we are going to stop the division. We have obtained the quotient that we need, which is 3x plus 18. And this quotient is what gives the oblique asymptote. So we'll say that the oblique asymptote would be y equals 3x plus 18, which in our case seems to be option C. So option C is the correct answer. Question 29. Which variables would change if the function y equals a cos bx minus c plus d, where a is positive, was changed to a curve in the form y equals a sine bx minus c plus d? So what we have in this case is the equation of a cosine and the equation of a sine function. So what we do see here is the coefficients a, b, c, and d, which respectively would describe the vertical stretches, horizontal stretches, and when we say stretches, we mean both compressions or expansions, phase shift, and vertical translation. So if we are changing, or if we're reading a function, a cosine function, as a sine function, if you remember, the vertical expansion or compression doesn't change. The period length, which is defined by the coefficient b, does not change. The vertical translation doesn't change. The only variable that changes is the coefficient c, which indicates the phase shift. The reason why is because a sine and a cosine function would change by a phase shift of pi over 2. For example, if we have a cosine curve, if we translated this curve to the right pi over 2, or to the left pi over 2, we get negative sign, right? Or to the left 3 pi over 2, then we get the sine curve. So the only coefficient that will change a cosine into a sine will be the phase shift. So we are going to say that the coefficient c is the one that will change in order to get from cosine to a sine function. Question 30. If the hydrogen ion concentration of a liquid is given to be 3.98 times 10 to negative 4 moles per liter, then what is the pH? So this is one of the very easy questions. It's easy if you remember the formula. So the formula for pH level is negative log concentration of hydronium ions. So therefore, we have negative log, concentration is 3.98 times 10 to the negative 4, which means that the concentration is, simply use a calculator for that, press log, the base 10, 3.98 times 10 to the power of negative 4, and the answer I got here is 3.4. So let's check and see if that's one of the options. So hydrogen ions cannot be equal to a negative number, so 33.4 is too much, so we're going to go right here. It's 3.4 is one of the options, and this is the right answer.